Fine. Uh, Today we are going to discuss a new algorithm development strategy, that is dynamic programming. Okay. We have learned three techniques: divide and conquer, greedy approach, and backtracking. After these three approaches, we are going to learn a new approach named dynamic programming. It is actually based on the principle of optimality. Okay, that is nothing but we can reach a solution through a set of decisions. Okay, and principle of optimality says whatever the initial state is, remaining decisions must be optimal with regard the state following from the first decision. This is the principle of optimality. The next thing is this dynamic programming methodology is used to find a solution for optimization problems. We have learned another approach for the same thing, that was greedy strategy. Then what is the difference between greedy strategy and this dynamic programming? In greedy strategy, there is a fixed procedure and we will follow that procedure and we will reach the solution. For example, we have learned Prim's algorithm to find the minimum cost spanning tree. What we have done, we always select the minimum cost edge and we will delete it from the graph. Then we will go for the next minimum cost edge. Okay, we first we have arranged all the edges in ascending order of the weight. After following this procedure, we will get the minimum cost spanning tree. But in the case of dynamic programming, we will find all the feasible solutions and we will pick the best one. This is the difference between greedy approach and dynamic programming strategy. Both strategies are used to solve maximization or minimization problems. So first you have to understand what is the difference between these two approaches. Both are used to find a solution for optimization problem. Okay, let us try to apply this dynamic program method uh, to find the nth Fibonacci number. Okay, so this is the recursive algorithm to find the nth Fibonacci number. If n equal to 1 or 2, it will be returning 1. Else, it will return Fibonacci fib n minus 1 plus fib n minus 2. Okay, let us see how to find the eighth Fibonacci number. Okay, so this is the tree. Fib eighth equal to fib 7 plus fib 6. Eighth Fibonacci number equal to seventh Fibonacci number plus sixth Fibonacci number. Okay. Then in this tree, see how many times we are calculating fib n. Sorry, fib 6. Fib 8 we are calculating and the function is recursive 1. How many times this fib 6 is calculated? You can see it here, here. Okay, two times you are calculating fib 6. Then consider fib 5. There is here you are calculating, here you are calculating, here you are calculating three times. Okay. Then what about fib 3? How many times you are calculating it actually? 1, 2, 3, 4, 5, 6, 7. Okay, 7 times you are calculating fib 3. Why should we calculate this repeatedly so many times? Do you remember the time complexity of this recursive algorithm to find the nth Fibonacci number? For the calculation of the upper bound, our recurrence equation was T of n equal to 2Tn minus 1 plus C. This was the recurrence equation used to find the upper bound of this recursive algorithm. Okay, what was the complexity? So let us use the iteration method. Tn minus 1 will be in every level it is decremented by 1 to Tn minus 2 plus C is equal to 4Tn minus 2 plus 3C. And in general it is 2 raised to k Tn minus k plus 2 raised to k minus 1 C. Okay, this will be the kth general equation, and the time complexity will be big O 2 raised to n. Okay, this is exponential. Okay, this is an exponential number. So the complexity is big O 2 raised to n, and this recursive algorithm it is exponential in nature. Okay, then if we avoid the repeated calculation of some fib k, can we achieve a better algorithm whose complexity is better than 2 raised to n? Actually, the exponential is always bad. Okay, they are not good. We need an algorithm whose complexity is better than this. How can you avoid the repeated calculation? Very simple. If you memorize the value calculated, when we are recording the value of 5k when it is calculated first time. Once again we encounter the calculation of 5k, we will check the recorded values. Whether it is recorded, we will take the value directly from that. Otherwise, we will go for the calculation. Okay. See here the fib 6 is calculated here when we are finding a value for fib 7. Okay, when we have need a value for fib 7, we have to calculate fib 6 and fib 5. Fib 5 is calculated at this point actually. Okay, then we can avoid calculation of fib 5 at this node or at this point if we record the previously calculated value. For that, what will we do? We can maintain a table. Okay, we can maintain a table. we can maintain a table 1, 2, 3, 4, 5, 6, indices 7. Okay, and we will fill all the cells with value 0. Fill all the cells with value 0. Okay, here this fib weight n not equal to 1 or 2. We we have to return fib n minus 1 plus fib n minus 2. Okay, then the fib calculation of fib n minus 1. Okay, we will come here. Okay, first we will be here, then we are here, then we are here, and here. Okay, this 3 again, 2 and 1. Okay, here we are going to calculate fib 2. Okay, what is fib 2? From the algorithm, that is 1. Okay, so fib 2 we are calculating, so we can record that. Okay, we can record that. Fib 2 we have calculated, it is 1. Fib 1 we have calculated, it is 1. We are calculating fib 1. Okay, that time we are recording that. Okay, now we can calculate fib 3. Fib 1 we have calculated, fib 2 we have calculated. Now we can calculate fib 3 and record it. Fib 3 is 2. Okay, fib 3 is 2. Then fib 3 we have calculated. Then here we have to calculate fib 2. After calculating fib 3 and fib 2, we can calculate fib 4. Fib 4. Okay, so what is fib 2? No need to calculate that. No need to calculate that because it is already calculated and recorded. Okay, so when we are here, we have to modify the algorithm. Okay, when we are here, we have to check whether it is calculated. If it is calculated, so it will have a non-zero value. It is 1. Okay, so here you can see it is 1. So no need to calculate it. Okay, so no need to calculate this because we already calculated. Here we can fib 2 its value can be taken from the table and we can calculate fib 4. What is fib 4? What is fib 4? That is fib 3 plus fib 2. It is 3. So fib 4 is calculated. We can record the value. Its value is 3. Fib 4 is calculated. And next we are going to fib 5. For that we have to calculate fib 3. Fib 3, no need to calculate it again. No need to calculate it again. Once we are here, we have to check the table whether it is calculated or not. It is actually calculated. Okay, it is fib 3 is already calculated. We can take these values fib 3 and fib 4 from the table now and add them and find a value for fib 5 and record it. Fib 5 is recorded. Okay. Next, we are here to calculate the value of fib 6. Okay, from here we have reached all these places. Okay, we are coming back. Then we need two values fib 5 and fib 4. See these two values fib 5 and fib 4. These values are available in the table. Okay, so we will take this value from the table and calculate fib 6. So fib 6 is calculated. Okay, so 6 is calculated. See, since we have taken the value of fib 4 from the table. See the nodes below this we have not considered. Okay, we have not considered. Then fib 6 we have calculated. Then we need fib 5 to calculate fib 7. What is fib 5? No need to go through all these nodes. Not necessary to go through all these nodes below it because fib 5 is already calculated and recorded in the table. Fib 5 is already calculated and recorded in the table, and we will take its value. Now we have fib 6 and fib 5 both in the table. We are calculating fib 7 and recording it. Okay, fib 7 and recording it. Calculating fib 7 and recording it. So fib 7 we have calculated. Now to calculate fib 8 we need fib 6. See, no need to calculate all these things, all the nodes below. Okay, because fib 6 is available in the table. It is 8. So fib 8 is 21. Okay, so no need to go through all these nodes. Okay, so how many nodes we have visited actually? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, nearly 14 nodes. Okay, that means we can see we have visited some n plus c nodes. Okay, we can see t of n equal to some n plus c, and it will be of order big O n. Okay, so previously our recursive we have modified this algorithm by introducing a table. Okay, we are memorizing these values, and by this dynamic programming approach we got an algorithm with less with a better time complexity for big O n. Okay, so in this way we can use this dynamic programming approach to alleviate the task of finding nth Fibonacci number. Okay, we will see the remaining problems in the next videos. Thank you.